1.4, complex numbers preparation. So we're going to factor of a number are also divisors of the number. The greatest common factor is the same as the greatest common divisor. Here are some divisibility rules for deciding what numbers to divide into a given number. This is actually not a bad idea to memorize these. You don't have to. But again, it's not a bad idea if you do. So for instance, if a number is divisible by 2, it ends in a 0, 2, 4, 6, or 8. If it's divisible by 3, the sum of the digits are divisible by 3. So for instance, if you had 18, 1 plus 8, right, is 9. So let's do an example of this really quickly. So 18, right? So 18 is 1 plus 8 is 9. 9 is divisible by 3. Therefore, 18 is divisible by 3. That's what they mean by that. The last two digits from a number divisible by 4. Okay, so for instance, let's say 164. Right, so 64 is divisible by 4. Therefore, 164 is divisible by 4. If it ends in a 0 or a 5, so for instance, 100 or, 105, right? So that's divisible by, so it ends in a 0. And this ends in a 5. Divisible by both 2 and 3 means it's divisible by 6. So for instance, I guess I could go back to 18. So 18 is divisible by 2 because 18 is an even number. And it ends in 0, 2, 4, 6, or 8. And it also is divisible by 3 because the sum of 1 and 8 gives you a 9, which is divisible by 3. And I've already proved that under 3. So since this passes both of those, we would say 18 is divisible by 6. So 6 is simply a combination of rules for 2 and 3. Next we see 8. Last three digits form a number divisible by 8. Last three digits form a number divisible by 8. So I guess we say 1,128. Let's see if that works. So last three digits form a number divisible by 8. So it's 128 divisible by 8. Let's check it out. So we can go in and, oops, did that upside down, my bad. There we go. All right, so we divide that by 8. So 8 goes into 1 once. Boom. And then we have 120. 120, it looks like that would be 15. So looks like a total of 16 times. So it goes into 16, so it looks like this checks off. Sum of digits divisible by 9 would be this one. So for instance, 126. So 126 is divisible by 9, right? Because you're saying 1 plus 2 plus 6 gives you a 9. And 9 is divisible by 9. So it looks like that's good. Or it ends in a 0. So it's basically just the first part of the 5 one. Okay, so they're saying find the greatest common factor. Okay, but basically what that means is the largest number that will divide into both of these. So this is basically the question they're asking. What is the largest number that I can divide evenly into both a 30 and a 45? Now, if you're pretty good with your division rules, then you would know that the answer to that would actually be 15, because I can divide both 30 and 15, or I'm sorry, and 45 by 15. This would give me a 2, and this right over here would give me a 3. Okay. Now, as the numbers get larger, you're going to find this more and more difficult. Also, you can try to find the greatest common factor of more than 2 terms. So you might be required to find it in 3 terms, 4 terms, even more. So we need a little more advanced method. And what we do is we do the prime factorization, just like we did a long time ago for the least common denominator or least common multiple. So it starts off the same, but our interpretation is going to be slightly different. Okay. So the first one is 2 times 3 is 6. 6 times 5 is 30. Oops. So we don't actually need to rewrite that one. That's what it is. This one over here is 3 times 3, so we say 3 squared multiplied by 5. So what we do to find the greatest common factor is pretty much the opposite of what we did for the least common multiple or least common denominator, in that we find each element not to the highest power, but to the lowest power. So if it doesn't exist in all of them, you don't get to include it at all. So for instance, in this one, if I'm trying to find the GCF, looks like I have a 2 here, but I don't have a 2 on the second one, so I don't get to include 2. I have a 3 to the first power here, and I have a 3 to the second power on the second one. So I'm just simply going to include 3 to the first power because 1 is smaller than 2, and it really is that simple. So, for instance, there was a 2 to the first power on the first one, but there's no 2 on the second one. Well, what's smaller than 2 to the first power? Well, 2 to the nothing power, or 2 to the 0th power. So that since there were no 2's in the second one, I don't get to include 2. Well, let's look at 5. I have 5 to the first power and a 5 to the first power now. So the lowest is 5 to the first power. Right? So we say is 3 times 5 is 15, which is what we got before. So that worked, right? So if the numbers are small enough, you can just use dividing rules and kind of mentally figure it out, or you can do the prime factorization and do it from there. Both ways work. So this brings me up to what I was talking about earlier, in that the numbers get much larger, and there can be more than 2, in which case it gets harder and harder to mentally figure out what the GCF is going to be. So we are going to do prime factorization. Now, previously I didn't actually write out the prime factorization, and that's probably not a good thing. You probably need more examples of that, so let me try that. So to get the prime factorization, we need prime numbers. Prime numbers are numbers divided by themselves in 1. So 2 is a prime number because I can divide 2 only by 2 and 1. 3 is prime because I can divide by 3 and 1. 4 is not prime because I can divide 4 by 2. 5 is prime because I can only divide 5, and this is evenly. 5 divided by 1 or 5. 6 is not a prime number because I can divide 6 by 2 and 3 evenly, and then it goes to 7, and so on and so forth. After a while, you'll just memorize them, but that's okay. You can just memorize the first, 6 or 7 of these, and generally speaking, that's probably going to be enough. They're an infinite number, so you're obviously not going to memorize them all. So what we do is we try to divide by the first prime number, which is 2. So I say 72 divided by 2 is 36, so that worked. And then divided by 2 is 18, and that worked. And then divided by 2 is 9, and that worked. 9 divided by 2 doesn't work. What's the next one? 3. Cool. So we'd say 9 divided by 3 is 3, and of course 3 divided by 3 is 1. So it looks like 72 is equal to 2 times 2 times 2, or 2 to the third power, times 3 times 3, or 3 squared. All right, let's try the next one. How about 120? Well, 120. So we divide by 2, we get 60. We divide by 2, we get 30. We divide by 2, we get 15. Did we divide by 2? We got 7.5. Doesn't work. How about 3? 15 divided by 3 is 5. 5 divided by 3, not even. 5 divided by 5, the next one, 1. Awesome, it worked. So we end up with 120 is equal to 2 to the third power times 3 times 5. Then we do the next one, which is 432, which is divided by 2. So it's 216 divided by 2, which is 108 divided by 2, which is 54 divided by 2. I know it looks like a 9. Divided by 2, which is 27. Divided by 2, we get 13.5. That didn't work. So how about 3? 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Whoops. 1. So we would say 120, we would say 432 prime factorization is 2 times 2 times 2 times 2, which is 2 to the fourth power, times 3 times 3 times 3, which is 3 to the third power. Okay, here we go. So it looks like we have a 2, we have a 2, and we have a 2. They all have 2s, so we just need to pick the lowest exponent, the smallest power. So we have 2 to the fourth power, 2 to the third power, and 2 to the third power. So the GCF, my handwriting's terrible. GCF is going to be 2 to the third power. Next, let's see what else we have. We have a 3 to the second, we have a 3 to the first, we have a 3 to the third. So it looks like we're only going to be able to include 3 to the first power. We have a 4 to the first here, but we don't have a 5. We have a 5 to the first here, but we don't have a 5 in the first one, so we don't get to include it. We don't have it in the last one, we don't get to include it. So all we end up with is 2 to the third power, right? Because 2 is in every one of them, and the lowest power is a 3. And we get to include 3 to the first power because 3 is in all of them, and the lowest power is a 1. We don't get to include the 5 because the 5 is only in one of them. It's not in the other 2 at all, so the lowest is nothing. You just don't get to include it, right? So the GCF of 2 squared is 9 times, 2 to the third power is 8. 2 times 2 is 4, times 2 is 8, times 3, which gives me a 24. Now, some of you would have been, you're good enough at your division where you can just mentally do it, that's fine. But it's good to know the more advanced method because this can and will break down, especially if you go much further in mathematics. And it's good to know robust algorithmic ways of solving things and not have to rely completely upon your ability to do mental math. Again, the more you write down, the less you have to keep track of mentally. And generally speaking, it's easier. The more steps you write down, the easier the math is. Takes longer, might be a little more arduous, but eventually you'll internalize the algorithms and then you can just do the math mentally with enough practice. But initially, you probably want to write everything down.